Hello everybody and welcome back. Today we're getting a little introduction to functions here. So throughout elementary school you may have remembered some of these in-out boxes where we're given a rule and then we got to plug a value into it, apply the rule, and we get a value out. So in this case our rule is +3. So our input is 2. Plug it into our rule box, take our 2 plus 3, and out of it we get 5. So what we're starting to do now is if we do a bunch of these in and out boxes, see how much space they take up. If we have to do a couple, we start taking up a lot of space on our paper, right? So what we're trying to do is condense all this information into a more user-friendly and space-saving table. So now our in-out boxes are going to start looking like these function tables to save us some space, to make life a little easier. So all we're doing is to find our y value, because we have a y equals here, all we have to do is plug in our x, apply that rule that the function tells us, and we get out our y. So if we plug x equals 1 into here, we get 1 plus 2. So when x equals 1, y is going to equal 3. Now we take our 2, plug it in. 2 plus 2 is going to spit out 4 for us. And then just like our in-out box above, we plugged in 3. Oh, sorry, this is different from our in-out box. It looked a little bit the same, sorry. So, but we plug in 3 for x. 3 plus 2 is going to spit out 5. 4 plus 2 is going to spit out 6. So these tables could go on and on and on, but since it only gave us these x values, these are the only y values we're interested in getting out of it. So all these are just relations between two sets of numbers. And what a relation is it is a pairing of numbers in one set, our x's. So we're pairing that up with a set of numbers in another set. So we paired our x and our y values here. So in the case of our function tables, it's just a set of ordered pairs, which is why we had our intro to coordinate plane yesterday, because all a coordinate plane is built up of is an infinite amount of ordered pairs. So we have some other names for x and y. So x will be known as our input. Whoops, not inpup. Input. Excuse me. Can be known as our independent variable or our domain. And then our y values are known as our output, our dependent variable, or our range. So we call y the dependent value is because, like in our table, y, the value we got for y depended on what we put in for x. And we could really choose anything we wanted to for x to get a y out of it. And that's why x is our independent variable. It doesn't matter what x is. All right, so all a function is it is a relationship or expression involving one or more variables. So some examples of functions, we have 2x equals 4. That's a perfectly good function. X plus y equals 19, also a function, one or more variables. Y equals 8, we've got one variable there, perfectly good function. So a function table describes a function by displaying its inputs and corresponding outputs in a table format. So our inputs were being our x values and our outputs being our y values. So this is all a lot simpler than it looks here. So all we're going to do is plug x, whatever we want for x, in to find out what y is. So here our function is y equals -3 times x. So all we're doing is plugging in the value we get for x to find out what our y is. So in this case, we get -6 for x, so -3 times -6 is going to give us 18. So our output, or our y value, is 18. Same thing, -3 times whatever our x is, so in this case, -7, is going to equal 21. So our output for our input -7 is going to give us an output of 21. -3 times -8, well, that's going to give us 24. So our output for the x input -8 will be 24. So a lot more simple than it looks here. All right, so for try these, what I want you to do is pause before each example here, try it on your own, and then compare it to what we get here to see how it went. So go ahead and pause it, give A a try here, and then compare it with what happens next. So I'm going to go ahead and get going here. So we plug in our x values to get our y values out. So when x is -2, we get -4 times -2 is going to give us 8. 8 plus 6, we get a y value of 14. -4 times -1 will be 4. 4 plus 6 is 10. Plug in 0. -4 times 0 is 0. And 0 plus 6 is 6. And finally, 1. We get 1 times -4 is -4. -4 plus 6 is 2. So pretty simple here to get our outputs from our inputs. We just apply the function rule that is given to us to figure out what an output is for a specific input. All right, so once again, pause for part B, and then compare it with, give it a try, and then compare it with what you see here. All right, so don't get confused by the fractions. Fractions are our friends. They're nice and easy. 1/4 times x. So in their first case, our x is -8. Remember, we can do some cross multiplication too. I could divide by 4 on both sides. So multiply across the top, we get -2. Multiply across the bottom, we get 1. So in this case, we get -2. So 1/4 times -8 gives us an output of -2. I'm going to start doing these quickly now. So 1/4 times -4 is going to give us just a -1. 1/4 times 0, well, it's pretty easy. Anything times 0 is 0. And 1/4 times 4 will be 1. Alrighty, so part C, remember, pause the video, give it a try, then you can play through and compare what you got with what we get here. Alrighty, so our function now is x squared minus 5. So we're going to plug in our x's. So x squared, we get a 5 squared, which is 25, and then minus 5 is 20. So for the input 5, we get an output of 20. 10 squared now is 100. 100 minus 5 is 95. So input of 10 for this function gives us an output of 95. 15 squared is 225, if I'm not mistaken. So 225 minus 5 is 220. And finally, last output, 20 squared is 400. 400 minus 5, we get an output of 395. Alrighty, so this last one, a little bit more complicated. We got a lot going on here, but don't get too flustered, so give it a try. Pause, give it a try, compare with what I get here. So, -4 squared, that'll be 16. and then half of negative 4 is negative 2. So 16 plus negative 2 is going to give us 14. Negative 2 squared will give us 4. Half of negative 2 is negative 1. So 4 plus negative 1 will give us, or 4 minus 1 will give us 3. All right, so now we get positives, which will make things a little bit easier here. So 2 squared is 4. 1/2 of 2 is 1. 4 plus 1 will give us 5. And then finally, we got 4 squared is 16. Half of 4 is 2. 16 plus 4 is 18. All right, so I know D here was a little bit complicated. This is just for an example for functions. We're not going to be doing anything with any this complicated of functions this year. So this was just kind of a practice for using our order of operations here to figure out what our output values would be. So that's about as complicated as things are going to get here for these function tables. All right, so there is an assignment to get done on Canvas and possibly an IXL to go with it, so just be sure to check for that. And as always, if you have any issues, feel free to send me an email, and I will get back to you as soon as I can. All right, so good luck on your assignment. Make sure you get that finished up and turned in, and I will see you guys on Monday for a new lesson.